Okay, so today we're going to talk about the Levi Civita and the cross product. So let's start. First off, this might be something you won't need to know until a little bit later, but I'm going to go ahead and throw this into the E&M section because the first bit of at least the Griffin book is math review. And I've already done a series, well, not a series, but I've done a decent video on vectors and kind of the basic properties. So I'm going to probably put that in the next playlist after the intro video. And then I'm going to go ahead and get into a little bit heavier math that might be a little more specific. Will we use this in E&M? I don't think it shows up later in the book. It might. This will be a little helpful for other physics courses, but nonetheless, we'll cover it now because it's helpful to know. So first off, let's talk about the cross product. So vector A and vector B, if you cross two vectors, you'll get another vector C. And the way I like to compute the vector, or compute to find the vector, compute the cross product, is it's the determinant of, I'm going to call this I, J, K. And this will be my X component for A, my Y component for A, my Z component for A, and then same thing for B. And I talked about this in the previous video, which you can check out how to determine the cross product. But basically what I do is I start over here and I just cover this whole side. So pretend it's not here, and then cover the J and the K, the unit vectors up. And what we're left with is AY, AZ, BY, BZ. And now we can do Cramer's rule, which is AY times BZ minus AZ times BY. And that's the I component. So AY times BZ minus AZ BY. And that is our I component, or our X component. Then we do a minus, and we'll kind of figure out why that's a minus today. I'm going to go ahead and do it really quick. Hopefully, if you don't understand that, watch the last video, and we'll talk a little more about it. Let's see, that's AX BZ minus AZ BX Y. And then plus, let's go ahead and do it really quick, AX BY minus AY BX Z. So now we're going to look at another way of computing this. And just so we know, for our unit, EX is the same thing as the unit vector here. You might see it like this. You might see it like this. Okay? All right, so let's look at this. Now I'm going to write something and you're not really going to understand what it means at first, but that's okay because we'll go over it. So it's a little epsilon with these indices here is equal to 1 if we have a citric putative, permutation. It's -1 if it's anti-citric. So let's see. And it's 0 for all else. So if you haven't clicked off the video, that's good because we're going to talk about this. First off, let's imagine we have a number line. And let's say the number line starts at 1, there's 2 in the middle, and there's 3 at the end. And those are the only 3 numbers on our number line. And the other interesting property about this number line is once you get to 3, if you were to start counting, you just go back to 1. So we start at 1, we go 2, 3, 1, 2, 3, 1, 2, 3, 1. Hopefully that makes sense. So when we say, so when we go in order like that, 1, 2, 3, or 2, 3, 1, or 3, 1, 2, that's when we get our 1. Now, if we get our -1, it means it goes backwards. So 3, 2, 1. 2, 1, 3, 1, 3, 2. So it just means we go backwards. And if it's in any other combination of that, it's 0 for all else. Like, okay, that hopefully makes a little more sense, but there's still a lot more we don't understand about this. Like, what even is this? Well, here's what we'll do. First off, let's talk about the indices real quick. So I, this is the important one here. I is equal to 1, corresponds to x. I equal to 2 corresponds to y. And I equal to 3 corresponds to z. The components of the vector. So when I is 1, we're talking about specifically the x. When I is 2, so when I say that, I'm talking about, let's do this actually. So when we're talking about the x, we're interested in this part of our cross product. If we're talking about 2, when I is equal to 2, then that tells us we're looking at this part, that we're looking at the y part. And lastly, we can let I be 3, and in that case, we're finding the z part. The z part. So hopefully that makes sense. At least we're starting to break this down a little bit. Okay, so the next part I want to show you is A cross B. You know what that is. Then down here, I'm going to put I, which is the I we're talking about over here. I'm going to keep it just I for now, but we can let that be 1 or 2 or 3 or whatever we want. That's equal to the sum of j equals 1 to 3, the sum k equals 1 to 3 of epsilon I j k times a j b k. So let's look at this real quick. Again, this looks scary. It's not, don't worry. This, the good news about this ugly looking thing is it's either going to be 1, it could be -1, or it could be 0. There's only 3 options. So that nasty looking symbol with these letters down on the right hand side, that's not going to be that nasty. It just looks weird. And then we're just summing from 1 to 3, so a small sum of this, of A, J, and BK. Okay, so let's work an example, and I think it'll make more sense. Let's go ahead and say A cross B. Now for the first example, I'm going to work it out real slowly. It doesn't have to be this long. I just want to make sure we understand what's going on. And we'll say 1, right? We'll say I is 1. Okay, well, what's that equal to? Well, we have our sum still. That doesn't change. And then we have epsilon 1 jk, because we said I is 1. Okay? And then we have a j bk. Okay? And they start at 1 and they go to 3, so you can only have so many options. Okay? So let's go ahead and start expanding this a little bit. Epsilon 1, we're going to start adding. Now, j and k can be 1, 2, or 3 in any order. So let's just start with epsilon 1, 1. Let's see, we said j is 1, so that's a1. Or k is 1, so that's b1. We're summing, so let's do it again. And let's say that the j component is now 2, and we'll keep that part 1. So that's a2, b1, plus, can you guess what this will be? 3. Okay. let's see, I can fit out a little more, plus, let's say 1, 1, 2. So that's A1, B2 plus, let's see, can I fit a little more? Plus, let's do epsilon 1, 1, 3. So that's A1, B3. So I'm just matching this with the K, this with the J. Okay, let's come down here. So that's a few. Let's see, what else can we do? We could do 1, 2, 3, right? And that's A2, B3. What else could we do? We could go 1, 3, 2. That's A3, B2. Okay, so we expanded it all out, and I think you can see it'll start to clean up nicely if we look over here. So let's start with, for it's 0 when it's anything else. 1, 1, 1. So this is just 0. This goes away. 1, 2, 1. That goes away. Basically, if they repeat, they're going to go away. 1, 3, 1. 1, 1, 2. 1, 1, 3. 1, 2, 3. Okay, well, that doesn't repeat, and it goes in our order, right? 1, 2, 3. So that's just, I'll do a different color. That's just 1. And what do we have? 1, 3, 2. 1, 3, 2. That's going to be -1. So we have, this simplifies to A2, B3 minus A3, B2. Or if we're doing it where 1 equals X, 2 equals Y, 3 equals Z. A2, so that's AY, BZ minus AZ, BY. And we said I is 1. Boom. And that's what we got from our, when we did it over here, AYBZ minus AZBY. So again, we went really, really slow, and that's okay. But practically, it doesn't make sense to write it out like that because that takes a lot of time. So let's do this. Let's do the next one a little quicker. A cross, let's write that a little nicer. A cross B, 2. So this tells us we're looking for what? That tells us we're looking for the Y component. Okay, well, again, this is the sum. I'll write the sum one last time of epsilon I j, but we're letting that be 2. So that's 2jk aj bk. Okay. Now let's think about this. We said basically anytime we see these terms repeat, 1, 1, 1, that repeats 3 times. 1, 2, 1, 1 repeats 2 times. 1 repeated twice. 1 repeated twice. 1 repeated. Whenever you have these numbers repeat, they're going to cancel. So the fact that I know 2 will always, always, always be here, that means J and K must equal 2, 1, 1, and 3. That way we don't get anything to repeat. So even though I have the summation there, I'm going to go ahead and do the canceling basically in my head, which is kind of nice. So the I is going to be a 2. Let's see, it could be 3, 1, right? And what's that? That'll be A3, B1 plus, what do we have? We could do epsilon 2, 1, 3. And what's that? A1, B3. Okay, which is AZ, BX, Z and X. This one is 2, 3, 1, so that goes in order. That's 1, 2, 1, 3. that goes backwards. That's -1. So this is minus ax bz, which looks a little different than we did with the cross product, because with the cross product, remember, we always have that negative out front. But if you were to distribute this, what would you get? You would get azbx, which is what we got, minus axbz. And this is for your y. And then just to show you, a cross b, maybe try that one. 3. Well, we know it's going to be this. There's a sum. I'm not even going to write it because let's be a little practical here. Again, this is 3, so j and k must be 1 or 2. Go ahead and try it, and you'll see you'll end up getting axby minus aybx. So hopefully that helped, and hopefully it makes more sense.